As far as contentful reflections from yesterday, yesterday we went through a couple of areas of significance during the boot camp. Yesterday morn, we took a look at how we could capture evolution of an individual through discrete state categories using where we have multiple types of concerns at issue. So we had individuals with a smoking status, we had individuals with a status with respect to heart disease. And far from being solitudes, these two were interacting, as you'd expect. Heart disease, the hazard rate for developing heart disease was materially impacted by the occurrence of smoking. And we noted that we could capture reverse reciprocal causality as well, where occurrence of heart disease might change smoking behavior. Both of these were readily accomplished through several mechanisms in any logic. One of them that we explored yesterday was the use of variables. So we had variables that communicated hazard rates back and forth. Later in the day, Winchell and Kurt captured interagent interactions using a different sort of mechanism. And it was a little bit below the hood because at the level you were dealing with models, but they certainly spoke about it, which was messages, using messaging to communicate between agents. So I want to draw a distinction between those. When we're dealing with ongoing interactions, ongoing causal influence, often we end up using something like the first of those mechanisms. We have a hazard rate that's increased and it persists on an ongoing basis. When we have episodic interaction, particular events of interaction or occurrences, instances of interaction that occur for just a very small period of time, we'll often use messages for one to influence another. And even within a person or agent, we can capture these episodic interactions between state charts using events sent from one state chart to the other. So perhaps, for example, there's an event associated with a use of a drug, of a narcotic, and that might send a message to another state chart which captures attitudes towards narcotics, or that captures the fact there's a risk of developing addiction from that episode, something along those lines. Or a more pertinent example for work of Narges, who I believe is in the room or in the wings, or pertinent from Tina, is characterizing HIV-related interactions involving episodes of sexual contact or needle-sharing contact. So it could be that for a given episode of shared needle use, there's a certain risk someone will become infected. And so this might involve interactions between state charts that's episodic rather than an ongoing risk day after day that's conferred. And there we might use a message rather than an elevated hazard rate. Okay? Depends on the scope of the model, the level of detail which we're capturing these actions, but it's not unusual for us within an agent to use messages to capture these inter-concern influences that are brief in duration but of significance. And other times, we'll capture changes in state another way. For example, we might capture the occurrence of a use of a cigarette on the one hand, and have it essentially represented as an instantaneous event, good enough approximation for the sake of our model perhaps. And during that event, it ups the amount of substance in the body, the nicotine level in the body, which then decays according to metabolic processing by the liver. And there the occurrence of this event of smoking might increase the stock, and that stock then decays according to a first delay outflow due to the metabolism of the body. That would be another way that you might have inter-concern interactions, with one having to do with smoking behavior, the other having to do with the physiological or the metabolic sort of state of an individual. Okay, so it's not unusual that we have these interactions. How we capture them differs a little bit in each circumstance. And in the models that we have provided you, you'll find many such little examples of different ways of approaching these things. Tomorrow, or this afternoon, I'm hoping to work with each of the teams as a sort of Santa Claus of sorts. I want to go to each team and I want to identify the models that we have most germane to that team's interest, and I want to provide those to you. Many of those are in the thumb drives that we gave you. Some of those are not in the thumb drives, but are ones that we've created. We can't distribute freely because of encumbrances, collaborative teamwork involved, and pre-publication or what have you. But I want you to be able to know about these at the least, and if possible, to be able to give them to you with appropriate guarantees, and knowing that your particular problem is somewhat different. So we have a lot of models like that, and I want to make sure that you have recourse to them, and that the TAs could walk you through them, an appropriate TA. So this afternoon, I'm going to try to play Santa Claus. I'm not sure I'm going to finish all day today, and despite the musings of my colleague Cord Stange, I don't think I'll grow the requisite white beard that, as the visitor we saw in Southern California, will be something I look forward to having in my older years. Okay, so right. So content yesterday, not of a hirsute kind. We continued on yesterday to look at networks, and Kurt walked you through, and Winchell provided some additional insights related to models of contagion in any logic, which involve not just one type of network, but multiple types. And this is not a rare thing. In the HIV models, led by Narges and by Tina for Vietnam and Saskatchewan, respectively, we'll have different network types. So we'll have a social contact network or set of interactions, and we'll have a set associated with needle sharing networks. And in many other cases, we might have a familial or a collegial network. These are very easily captured in any logic with multiple network structures. And I like to believe, and I think it's actually the case, that it was Jeff and I poking that eventually got AnyLogic to add these features, because they hadn't anticipated that previously, and we argued that in health it's extremely important, and we were listened to. These multiple network types can be associated with different features, whether it's directional or not. You can process messages come through on one, and distinguish those from messages coming through on others. And those networks may have very different rates at which they change over time. Winchell spoke a little bit about dynamic networks, and more so about capturing affinity, assortivity, preferential attachment within networks. Once again, we did provide you, and I made an utterance that pointed to it, pointed to a model that captures preferential attachment within these models in a more general sense, assortive and disassortive individual association between individuals that we provided you. There's an additional model that we had which spoke to another issue they mentioned, which was importing empirical network structure. So, like probably many of you in the audience, I've done my share of work with tools like PIEC or UCINet, or more recently ORA, ORA, out of Carnegie Mellon, and Gephi, to characterize network structure. Social network analysis is its own sub-area methodologically, and it's an area in which I have a passing measure of familiarity and strength. It works extremely well with the sort of agent-based models that we conduct, and often we'll do some network analysis in addition to modeling. And our afternoon speaker, Yuan Tan, if anyone is interested, has actually done a quite impressive amount in the Saskatchewan context with TB data, for example, doing social network analysis related to some of the modeling work she's also done. We have AnyLogic models that are designed to import files from some of those. So I remember there's one that I created back in the day for PIEC importing. So we can import a network file as saved by the PIEC network analysis and put it directly into an AnyLogic model. It creates the requisite agents and the links between them. And that allows us to then simulate the spread of contagion, whether it's rumors or memes or innovations or pathogens throughout that network. Readily available. We didn't include it because there were some technical issue that prevented it from being ported to AnyLogic 8 trivially, and we didn't have time to fix it on Sunday, so we just deferred it. But if anyone's interested, we're happy to give that to you. These sorts of models that work with network data can further be used to work with dynamic network data. And Windchill, in his inimitable fashion, has a long history of interfacing AnyLogic for years and years with data on extremely dynamic network structures captured by smartphones. Every 5 minutes, many of you know, we have this system, the IEPI system. The latest version is Ethica, which runs on Android and iOS smartphones. And it has a strong ability to record network contacts between individuals carrying smartphones and with these, most recently with these Bluetooth beacons that can be used to sort of place on certain locations or place with other actors such as dogs or animals or what have you. Cheryl's used it quite a lot. It has many other features in terms of GIS and location-based messaging and the use of survey instruments, etc., that I won't go into here. But the point is that it gives you very detailed network structure that can be downloaded, and Windchill has done a lot of work with importing that into AnyLogic. So we capture over a 3-month period, for example, every 5 minutes, people's network contacts, and we simulate the impact of spreading contagion through that network over that 5-minute period. Now, we first started work on that in 2009, 2010 with a much simpler system, but more recently it's made very, very simple through the use of these tools. And Windchill has a long history of doing this, saving that data, say in databases or in files, and importing it into AnyLogic. So if any of you are interested in extremely dynamic network data, Windchill's your man. Windchill's your man. And I think he'll be rolling in here in a few minutes here. Okay. Great. So yesterday we aspired, but one thing we didn't get to yesterday is building interactively together, building a model of contagion, building up step by step a model where we have spread of contagion throughout a network. They showed you models that were pre-built. How many people here would very much like to see, if we could do it within an hour's time, how many people would be interested in building together a model of that sort of network spread of influence? Okay. Kurt tells me with me, the eyes always have it. Kurt, so as an objective measure, should we get them to raise their hands again so you can?
No, I wasn't watching.
Okay, yeah, so could please people raise their hand again if you would be interested in building together a network?
Pretty universal. Yeah.
Okay, okay. Great, so it shall be. We'll bring this in, and I will cogitate. I will cogitate about exactly when we do it today or tomorrow. Okay. Thank you very much for your indications of interest. In the afternoon, thank you. Oh, Alan, there's a few more people that have come in.
Okay.
Maybe you could check if this remaining mouse is needed.
So anyone with a laptop that would like the mouse to build maps, it's much easier.
Yeah, we're building GIS maps this morning. Is there anyone who, and mice make it much simpler.
There we go.
So Alan has distributed a plague of mice, and this is now the last of them, I believe, right?
Get some more from.
Oh, we're importing more mice?
Another plague.
Okay, maybe we could get some from some neighboring farms. Sorry?
You can just unplug from the computer.
It's difficult. They're tied in really tight.
Okay. Power to you. I admire ambition and enterprise. But yeah, I didn't want people to have to. Anyway, enough said. Okay, so the final thing yesterday that we did as a group, a broad group, was we built up or we continued our building up of a model, development of a model with an open population. So we have people coming into the population through an immigration process, dying out due to differential rates of mortality from heart disease and without heart disease. And we saw how we could incorporate age structure. Now, sometime last night, so I was operating last night on one cylinder, right? Thank you. No, I'm doing well, thanks. I only, in case you were wondering why I was drinking so much tea, I had 1 or 2 hours of sleep before yesterday, so I was operating on sort of limited deck of cards. Today I got 10 to 11, so it's not bad. An average is out to a not bad average, but it's nonlinear, and so the average is not indicative of the average of the function of the average is not the same as the average of the function applied to the distribution. Anyway, yesterday we had a exploration of this open population model, and I neglected to go back, and it sort of troubled me last night that I didn't go back and show an important feature, which is how when we added a parameter post hoc to capture age, it turns out parameters need to be specified for when we add people into a population. And indeed, when we have a population where those individuals are included in it, we need to specify something. So I'm going to open up that model just to show you where this is and point out the point of my failings. It wasn't included in the deck of cards that it was my
stack yesterday. So when we go, so you may recall that we added in to capture age within the model. We did it by capturing their continuous age by having their birth time. And whenever we ask this function, what's their current age, it would compute dynamically on the fly. It would compute their current age as the difference between the current time and when they were born. So time was measured in years. So if they were born at year minus 10, and it's now year 2, they are 2 minus 10 years old, or 12 years old. And we had this current age that was incrementing. And the notable point here is we had a parameter associated with it called birth time. That gave us kind of when they came into existence. And in a fit of lack of awareness, I neglected to go back, having done that, to Maine, to the population, and highlight the fact that now for the population we have to specify their birth time. And in fact, I think I left this blank and it just used 0. And I stand wholly remiss in this regard. We instead could draw here from this, from an age distribution, for example, like we put into place for the first model, and we could go import that age distribution. Or we could draw from a distribution here. We could say minus uniform between 0 and 80 years old. Now, why the minus here? Why do I put in minus? I'll give you a hint. Time starts at 0. So why am I putting in a minus before their birth time? Let's suppose there's someone who's 50 years old starting when the model starts at time 0. When would they have been born? Time minus 50, right? If they're 10 years old when the model starts at time 0, they were born at time minus 10. So if we draw their age from current age from a distribution, and it's time 0 now, to make that their current age, in effect, we need to say they had a birth time of minus that current age. Does that make sense? Yeah. So we should have done that. That's one place I should have done, and I stand remiss. Now, some of you may wonder about this whole idea of bringing in from another model. I heard questions about it yesterday from Patricia, and I think it's a great question. How can I draw on a past model, put things into a new model? It's particularly germane because we've given you perhaps 100 or so different example models, and you may want to bring features of those. So I'd like to show you how I bring something into here, okay? And it will also let us do something nicer than just drawing from uniform distribution, which causes me almost as much embarrassment as some of my utterances yesterday. So I'm going to go open that model and drag it in here, okay? So I'm going to do File, Open. We're going to open up our model from the first day, which is on the website for your perusal and downloading and viewing pleasure and modification pleasure. It is called Population Heterogeneity, and you built it in this very room, not 2 days thence. Okay, so here we go. This is the very first model that we built, and excuse me, it's this one here that it loaded in. So notice it now has 2 models in it. We're going to take this age distribution here. Wait, give me this one. And I am going to copy it. And I am going to go place it over here into the smoking and heart disease and copy it in. So what did I do? I used, I copied it. You can do so either with the mouse or with Control C, or on Mac, I think it's Option C. And then I did paste. I could have done it from a menu, paste like this. You notice if you paste it multiple times, it'll create additional copies of it with successively renamed in such a way that the names don't clash. So this is age distribution 1. If we paste it again, it'll be age distribution 2. So I'm going to delete this later one. It was just indicative when you paste multiple things. So this is something called age distribution. We just brought it in from the other model. And that allows me, with some relief and some relief of my embarrassment, to simply say minus a draw from age distribution. How do we draw from this? Does anyone remember? We need to have this begin paren, end paren. It doesn't need any information to do its job. Despite giving it no information, it can give us back a double value. And that's how you read these things. I should note. If you go like this, you'll notice there's two things shown. And you may not initially have an appreciation for what's being shown. It's saying, hey, look, I've got something called age distribution, which is a custom distribution. If we put this in, all we'll have here is a custom distribution. We'll be telling, hey, your birth time is the whole distribution, and it doesn't know what to do with that. It doesn't know what to do with minus a distribution. They'll say, I don't know how to take the negative of a distribution. I don't know how to use that as my birth time. Instead, the second one is saying, look, if you do that and you call it, you get back a double value, which is, we know semantically, it's their age in years. So this is the one we want. We want the one that's a double. This last thing where it says main just says, oh, these things are in main. These things are supported by main. It's main that knows how to do it. And so technically, if I want to be as picky about it as I have at other times, we can do this dot age distribution. You notice I cleaned up after that. I should have been more careful. I can say, for example, this dot age, and I can start typing this age distribution. I go and I select this with the mouse. By the way, some of you saw this yesterday in the tutorial on Java. I go select it, and I can press enter, and it will fill it out for me, including the call to it. Okay. Do you have to do this dot? No. I find it's helpful for people to prevent confusing it with other cases for certain examples. So we're using it for this boot camp. Just to be very clear that we're asking ourselves what our age distribution is, drawing that value from there by calling it and taking a minus of it. Okay? And that's one place where we need the age distribution. The other is actually in this immigration event, because this is a place where we're adding people to the population. And when we add them, by all rights, we should be adding them with a certain birth time. We need to specify what their birth time is. Otherwise, we'll use the default value, which in this case is 0. So here, we should have added them with a certain assumption about their age. And maybe in our situation, immigrants skew towards the younger side. We could have an immigrant age distribution that's a custom distribution for immigrants. Here, I'll assume immigrants are located between 0 and 50 years old. So I'll say minus uniform from 0.0 to 50.0. So what's going on here? We're drawing a value from this. We're taking its negative because we want to, we want to specify this is not correct. We want the current time minus this. Okay, why is that? Well, the idea is someone's coming in as an immigrant. If they're 25 now and it's year 50 right now, then they're 25 years old because 50 minus 25 is 25. They're 25. I'm not explaining it well. They were born 25 years ago. So their birth time is the current time minus 25 years. Let's suppose they're 40 years old. It's currently time 50. their birth time is 50, the current time, minus their age right now when they come in, which is 40 years old, so they were born at time 10, okay? So we're specifying their birth time given their age. This, we'll draw their age from this, and we'll subtract it from the current time to find out when they were born. And we're adding them in with that as their birth time. Does that make sense? Yes.
How does it know that that value is going to be the parameter?
Good. Good question. So let's and this is why I stand so singularly remiss. I'm going to show what I should have done yesterday. You notice when I do add population now, it actually gives me two options, okay? The first of them is tempting but dangerous, and you should generally avoid it, okay? The second is more forces you to take responsibility, but generally in life that's a good thing. So this extra one is asking and say, look, you have two options. One is Kurt would put this probably with greater loquaciousness on, but one is kind of is copping out with a is the cop out the easy the sort of mirage of the easy and irresponsible cop out.
I think that was more loquacious than anything I've ever done.
Okay, we'll see in your defense. The second is the one that forces you to think explicitly about your assumptions and make sure you communicate those assumptions. Here, when we add someone to the population, we have to specify birth time. Why do we have to specify it? This is the key conceptual takeaway I want you to get from this. When we add someone to the population, we have to specify a value consciously for all of their parameters. Anahita is working. I saw Anahita enter the room. I believe the queen has arrived. And the queen, with respect to rightful talent, she's dealing with a model which has something like 20 parameters. So when she adds a baby to that population, you have to specify some assumption for every one of those 20 parameters. If we have parameters, remember, parameters encode assumptions, and they communicate those assumptions from the point of creation to the thing being created. When we're dealing with a person, the point of creation is either in the population, in which case we need to specify it, for the population, we need to specify what our assumptions are about the birth time for every population member, or more generally, for each parameter associated with a person, we need to specify its the assumptions about it. And when we add a person to the population, we need to specify this new person coming in, what are our assumptions about that person, about their characteristics. And here, that's what the second of these does, okay? This is what the second accomplishes. So we'll do add underbar population, and we have to specify something about their birth time. This one forces you to take responsibility, think consciously about it, because it's a parameter of that person, and parameters encode assumptions, and we need to think about our assumptions. We want to think about our assumptions for our model to be a good model. So here, for the birth time, the answer here is actually surprisingly simple compared to the other cases we've seen. So if we're adding a baby now, yes, this is not for a baby. For a baby, what would the birth time be? If there's a birth event of a baby, what would their birth time be? The current time. So for births, it's trivial. For immigrants, we have to think, okay, their birth time well, if they came in as a newborn baby, if they were born as the flight landed in Saskatoon International Airport, they were being born. So they arrived as a newborn immigrant. Then their birth time would be now. But generally speaking, the immigrants come in not having been born at point of landing, point of arrival. That's generally a notable event if that's the mode of entry. Yeah. I can only wonder how many forms you're supposed to fill out as you cross. Well, anyway, I won't go into it. Okay. So here, ladies and gentlemen, we need to specify their birth time. If they are 10 years old now, the current time is now as we get through time, and they were born 10 years ago, then we have to subtract their age from the current time. And that's why I had this, that's why I had this thing, the current time minus something that gives me their age. And I'm just drawing it from a uniform distribution because I'm not terribly interested in going through the battle of adding in a new custom distribution. But it'll be easy enough for you to do so, and I leave it as an exercise for the viewer. So here we have adding them to the population with this as their birth time, and we are forced to think about, that's right, okay. So these parentheses match, okay? Great, so this is their birth time, and we need to specify that precisely because it's a parameter associated with them, and you really need to do that because it's irresponsible to just use the first. What will happen if you use the first? What do you think will happen if we do this? Other than a general way saying generally bad things will happen, what do you think will happen at a mechanical level? Where does it automatically get its values? Okay, so it's a good guess. It turns out it's not that smart. Generally computers aren't that smart. So it's actually not able to even be that intelligent. Where it will come from is something that I will show you, and I will show you with as a reminder of our responsibilities with any logic. Yet another responsibility on which I failed you yesterday. So if you go to person and you go to birth time, you'll notice that that there's a place for default value. Do you see that? Default value will be a value you use associated with the parameter if nothing is specified. Now in this case, I performed a doubly egregious action. And I suspect given my state yesterday, it may not have been the first of them that I performed inadvertently. So the default value, we should have put in something there, and I didn't do so, which is adding insult to injury. Not only did I use it, I never specified it in the first place, which is just shocking omission. And maybe that's why even in my impaired state yesterday, I was able to realize it well in the evening. So we should have specified a default value there in case nothing else is specified. And that would be the value that would be used if you didn't specify anything. Because I left it blank, it turns out in any logic, if you leave it blank, the way that parameters are specified, if it's a double parameter, it will just, if it's a double precision parameter, it uses 0 anyway. But here it was particularly opaque. Nothing was specified. So I apologize, mea culpa, for my transgressions, and I resolve to do a better job in the future and to be less irresponsible in my thing. Yes.
Excuse me my ignorance, but why you choose a uniform distribution distributive, not a Poisson distribution, for example?
We could use Poisson. Poisson is most commonly used for counts that are associated with, say, arrival rates. It's not immediately obvious to me. So, distributions in statistics are associated with classic data generating processes of certain sorts. And with a Poisson, if we had a memoryless arrival process and we were counting the number of events that occurred in some interval, Poisson would be an excellent distribution to use. I wouldn't anticipate that the age would be distributed in a Poisson way. And for two reasons. There's no data generating process for age like that. And the second is age in this model is continuous, birth time is a continuous quantity, and Poissons they're a count, and so they'll always have integer values. But your point, I think, is a more general one, which is, well, look, let's now wait a minute. Let's go look at here in our model. If we looked at this immigration event, we could have drawn here, not from a uniform, we could have drawn from any of the dozens of distributions here specified. We could have drawn from an exponential distribution that's continuous, or from a gamma, or what have you. We could have drawn from I'm not sure with Gumbel the nature, but we could have drawn from an Erlang, etc. And I accept your criticism on that. But in this very room, for this very course, we have gone through the exercise of creating a custom distribution for age. And given the limited time and the fact that people would like to see a model of contagion, I don't believe it would add, I believe the opportunity cost of going and adding a new distribution to capture age among immigrants would not be worth the time taken. I believe the opportunity cost would exceed the value of how we could have. The opportunity cost would be positive. We would be ruling out more important opportunities. So I'm not going to go into that. But if you'd like to change this, you could do so with delight. So I'm going to go copy it. I'm going to click on it. I'm going to hold down Control on my computer, drag, and it will create a copy of this. And I could call it immigrant age distribution. And you could engage in frobbing behavior to modify it at your pleasure. So here I'll draw people between 0 and 50 in a truncated way. And now for the immigration event, I will go and draw from that distribution. There we go. Immigrant age distribution. Boom, done. Okay. Done. Okay. But I regret the time being spent on that rather than on something new. Okay. So I will save this model away, and but it does make that, it enjoys the virtue of added transparency, because we could see, the logic of it is much clearer. And in that sense, Roberto's question adds to the clarity of this model. We have the current time minus the age of the immigrant is drawn from a distribution, and that gives us the birth time. If it's time 50 now, when they're 10 years old, they were born at time 40. And that's their birth time when we add them to the model. So since we're specifying this, if we went and we added a new parameter to the person, it's going to complain. It's going to exhibit displeasure. It's going to say, you have to specify their sex, the new parameter. And I think in other countries it doesn't always use that voice. But it's going to be, it's going to express displeasure in a more conventional fashion, and you're going to have to go and fix it up if you're adding parameters in. Don't do it,
but I will show you what happens, okay? Watch this. I'm going to go add in to person, I'm going to go add in a parameter for income. Here we go. Income, okay? Income. Boom. There it is. There's a new parameter. Don't do it in yours. Don't do it in yours, or else you may find yourself regretting it. And here I'm going to build the model, and it's going to be, I would expect it to be displeased. Yes, here it is. It says add population is not applicable for one thing. You have to give me two things. That's what that's saying. You have to give me two items here. What are those two items that we have to give add population now? Since I added in income, what are those two?
First time.
Yeah, birth time in here. How do we know it's the order? Well, it's a good little exercise to go see it. We know because we do autocomplete. Watch this. Don't do this, and especially don't do it at your home. See, now if we go select it here, it will say I need birth time first and income. Alternatively, read it over here. I need birth time and income, and it tells you what it does, of course. So this is telling the order in which it needs things. Yes.
So before I was doing something, so I wrote birth time equal to what we wanted to be specific, and it wasn't happy.
Yeah, I wish it were so. So in Java, you can't do that. Yeah. In the fullness of time, it may eventually be supported by Java, because Java is trying to compete with a language that I consider much more beautiful called Scala, which does support that. As you may know, that's well supported in other languages like R, where you can specify that, and where I use that to considerable advantage. In Java, you're not allowed to do that, and which raises risks, actually, because you got to know the order. Particularly if you have two doubles, if you switch them, it's not going to be smart enough to sort of say, oh, you're giving me their income from their birth time and vice versa. So you might have someone born with a birth time of, $30 billion if you're in the States. That could lead to unusual effects, both in civic society and here. So you have to be very careful about the order, because it doesn't allow you to disambiguate what you're trying to add quite explicitly. And this is a failing of the Java language, one of many that I could enumerate after hours if there were interest. Yes?
I struggle with this. One workaround that I've sort of developed in my own code is that you can put commands across multiple lines.
Indeed.
So you can put a new line character after one of the commas so that you can see all the things. And then instead of just putting numbers in, you put parameter names.
Yeah.
Does that make sense? So that you know it's not just 0.5, it's just parameter name that describes the thing you want. Does that make sense?
Yeah, or you go something like this. You go, here we could say something like, birth time.
That's right. So you can do that.
Birth time, and then this is.
The difficult part, though, for this is that you have to, if you change, sometimes if you add a parameter, or as you're building a model, it'll change the logic. So then, what I do is I just autocomplete the full version, right, with all the parameters that goes out. I put them on new lines, and then I can see which one. And if I name them the same as what they have in main, then I don't have to change anything. They're already named. And then sometimes you have to go through. So it's not ideal. The R way, where you can have default things and just specify one or two, would be sort of much better. But this is a bit of a workaround. You could also build your own add population function, where you default all this stuff, but then you take in two input values and you set them or whatever. So all of that stuff is contained within one function.
Yeah, and this is a bit conceptual to be describing it like this. You probably want to see examples, and we could show you many of examples with, not just with the teaching models we give you for this course, which are decidedly simple and they're simpler in their function to illustrate principles, but we could show you with operational models that we use for large, for industrial strength use. How you can contain the complexity associated with this when you have a dozen parameters or something, and you can be completely clear about what these things are. And Kurt, myself, Anahita, Winchell, we each have our tips and tricks, which have cross-informed each other. Yeah.
But we all agree that Scala is better. Or like
Darn right.
syntax.
Darn right. And Winchell, Scott doesn't know about this, but Winchell should show it to him. Winchell has hacked AnyLogic, so you can write code in Scala in it as well for yeah. So Winchell has actually gone and as normal he kind of did it on the side and showed me as a kind of curiosity that he could type Scala code in certain areas. Yeah.
Just to let you know, there is a known issue right now. At least some computing here, the property windows aren't updating when you're clicking on different objects.
Oh, okay.
I've sent an email to AnyLogic support through my account, and they've acknowledged they've gotten it yet. I'm waiting to hear back to see if there's a result.
Would you mind? Thank you very much. That's very helpful. Would you mind sending a further note to them asking why go-to population has been broken?
I could, yes.
That would be good. Iden and I think Winchell and Kurt could comment on our exact needs for it. Okay. But it screws up doing hierarchical models in the ways we've traditionally done them, and I figured there's a replacement. If you wouldn't mind checking it, that would be very helpful. Thank you. Okay. Very good. Any other? So Scott does AnyLogic training at AnyLogic events, and so he has some special channels back to St. Petersburg. Yeah. Okay. Any other comments or questions? You're welcome these things. And again, we could show you many models sort of on the side. Okay. Okay. Don't do the income thing. We don't need another one. I'm going to go get rid of income, and I'm going to distribute this model to you so you can look at it and adapt it to your pleasure. Very good. And I'm going to build this, make sure it's a happy camper. It's still. I still have a comma. Okay, yeah. Okay, here we go. Here's a comma. We don't need this comma. And I'll just pull this up here and we'll be good to go. Okay. Let's get rid of this space. There we go. Boom. Okay. So I'll distribute this model and we will proceed with our first GIS exposure, if people are okay with that. Maybe what we'll do is, just while I switch here, why don't we quickly take the break for physiological reasons, and we will reconvene here in 5 minutes for our GIS example, okay? Thank you very much.